Today, we're diving into the pretty wild and honestly mostly forgotten history of hydraulic power. It's a story of incredible ambition, sure, but it's really about a technology that wasn't just replaced, but was completely reborn.
So let me just start with a question. Picture your city's power grid, the invisible force that runs everything. Now, what if that whole grid wasn't electric at all? What if it was all powered by super high-pressure water flowing through a secret network of pipes right under your feet?
Sounds like something out of a steampunk novel, right? Well, for a while there, it was completely real. This incredible building you see here, this was a real-deal hydraulic power station in Antwerp. And those two towers, they weren't just for show. They housed these massive accumulators that were basically the pressurized heart of the whole city's network.
Yeah, back in the late 19th century, this power water was a real utility. You had this high-pressure water grid running underneath major cities doing the exact same job the electrical grid does today, delivering raw mechanical power whenever you needed it.
So that brings us to our first chapter, the golden age of these huge citywide hydraulic systems. It was truly a forgotten power grid of the Industrial Revolution. And you know what? This technology spread like wildfire. The big breakthrough was in 1850 with the invention of the hydraulic accumulator. A couple decades later, boom, the first public network is running in Hull. Then London gets in the game, and pretty soon, cities all over the world, Manchester, Sydney, you name it, they all had their own power water grids.
So what exactly was this game-changing device, the hydraulic accumulator? Well, the easiest way to think about it is like a giant mechanical battery, but for water pressure. It was basically a huge, heavy weight, just sitting on top of a cylinder of water. And that immense weight, we're talking tons and tons, pushed down and created this incredibly high and, more importantly, super stable pressure for the whole network.
The system itself was just a masterpiece of brute force engineering. You'd have these central steam engines pumping water into the accumulators, cranking the pressure up to around 800 psi. Then, from there, a whole network of cast iron pipes would distribute this power water under the streets, ready to run anything from giant dock cranes to the elevators in all the new buildings.
And the scale of this was just staggering. Get this, at its absolute peak, the London network alone had 184 miles of these high-pressure pipes hidden beneath the city. That is a massive, invisible circulatory system delivering raw power to thousands and thousands of machines.
But obviously, we don't have water power outlets in our walls today. A new kid was on the block, a new technology that was about to kick off a battle for the future of power. Electricity was about to change absolutely everything.
So why did electricity win? Well, it really came down to a few key advantages. See, water is heavy, and it loses a ton of pressure to friction over long pipes. Electricity, on the other hand, it could travel way further with hardly any loss. But the real knockout punch was versatility. You could easily divide electricity up, right? You could power a tiny light bulb or a giant factory motor. Hydraulics, it was kind of all or nothing, super inefficient for small jobs. The advantages of electricity were just undeniable. And while these hydraulic networks lasted for an amazingly long time, some for nearly 100 years, their era just had to come to an end. By the mid-1970s, the pumps had all gone silent.
But, and this is the whole point, this is not an obituary. The story of hydraulics didn't end, it just changed its address. The technology packed its bags, moved out of the city grid, and found a new home inside the very machines it was built to power. This is the story of its rebirth.
And the new driving force behind it all? A relentless obsession with performance and maybe most of all, efficiency. Like this modern engineering paper says, the game wasn't about brute force anymore. It was about smart power. It was all about how you get the most work out of every single drop of fluid.
And the difference is it's night and day. The old way, what you see on the left, that's like keeping your car engine floored at max RPMs all the time and just dumping all the extra power as waste heat. The new system, on the right, is smart. The pump gives only the exact flow and pressure that's needed for the task, right at that moment. It's pure, on-demand power with almost no waste.
This new philosophy just opened up a whole new world of efficiency. Engineers can now vary the pump's output, that's called primary adjustment, and they can also control the motor's speed directly. But the really incredible part is that modern systems can recover and recirculate energy. Kind of like how a hybrid car captures braking energy, these machines can actually share stored energy between their different moving parts. It's amazing. So this gets us to the very heart of this explainer, this fundamental shift in thinking. We're talking about going from a citywide, centralized grid to a decentralized, intelligent power source living right inside the machine.
This table really just lays it all out. Back then, you had a citywide utility running on water based on the idea of centralized brute force and pretty low efficiency. Now, the whole system is self-contained in the machine. It uses specialized oil and it's hyper-efficient because the principle is decentralized, localized precision. Okay, so what can we learn from this incredible journey? What does this whole tale of two hydraulics really teach us about how technology works?
What's just wild is that engineers understood the core strength of hydraulics way back in 1890. As this guy wrote, it is perfectly suited for intermittent action that needs a huge amount of force over a small distance. I mean, think of an excavator arm or a giant press. That basic truth has not changed one bit in over 100 years. And this, right here, is the key takeaway. We always think of technology as one thing replacing another, right? Electricity killed hydraulics. But that's not really the full story. Hydraulics didn't die. It just adapted. It found a new home, an environment where its unique strengths could be sharpened and perfected, moving from being a blunt instrument for an entire city to a surgical tool for a single machine. Which kind of leaves us with one final thought to chew on. In this constant hunt for more and more efficiency, for better performance, it just makes you wonder, what other powerful, obsolete ideas are out there, just waiting for the right moment and the right refinement to be reborn?